Hello everyone, thanks for watching my video today on graphing hyperbolas. To start with, we're just going to talk about what a hyperbola is. A hyperbola is a set of all points such that the differences of the distance from a point on the hyperbola to the foci are constant. A hyperbola will have two separate parts, or we call two separate branches, and there are two different types of hyperbolas, vertical or horizontal. So you can see in this chart, a vertical one will have this equation, whereas a horizontal one will have this equation. They're pretty much the same thing. The only difference is one of our constants is positive, one is negative. And that'll tell you what kind of a hyperbola it is. The positive tells you if it's vertical or horizontal. The negative will not be. The length of the transverse axis, that's the distance between the vertices, is 2 times a for both. The equations of the asymptotes, you can see that would be here. Okay, and then a quick sketch of each would look something like that, including the foci in the center. And to find the foci, we use this equation right here. Feel free to pause this video for as long as you need to take a look at this chart. Otherwise, we're going to move on to our first problem. Given the equation, find the center, vertices, foci, and graph it. All right, so because x is positive, this is a horizontally oriented hyperbola. The center is at -2, +3. All right, I'm just looking up here. I know that A is 3 and B is 4. So my vertices, we're going to move left and right 3 from there. So that'd be -5, 3, and 1, 3. And the foci, we're going to go c squared equals 9 plus 16. C squared is 25. C is 5. So we move left and right 5 from our center. There's our foci. Not pictured here are our covertices. They are important as well. We'll get to them in a minute. Let's plot everything we know. Center is at -2, 3. Foci at -7, 3, and 3, 3. Vertices at -5, 3, and 1, 3. All right, and like I said, not pictured are the covertices, but we're going to move 4 up and down from the center. So -2, 7, and -2, -1. All right. So now, in order to graph this, what we're going to do is we're going to make a box with the 4 vertices and covertices. Let's try to make a better box there. There we go. Now that box is not part of the graph, so it needs to be dashed. And then what we're going to do is we're going to draw some lines that go through the diagonals of that box. Those are also not part of our graph, so those also need to be dashed. Now, to graph this, we're simply going to plot 2 branches that follow those asymptotes to infinity. And there's our hyperbola. Okay, second one. The center is, well, first of all, I guess we'll do orientation first. Y is positive, so this is vertical. The center is at -4, +1. Right? -4, +1. So I already plotted that on my graph as well. In this case, A is 5, B is 2. So for the vertices, we're going to move up and down 5. Okay, the foci, c squared equals 25 plus 4. c equals plus or minus root 29. So our foci are going to be negative 4, 1 plus or minus root 29. Okay, so our vertices, negative 4, 6, and negative 4, negative 4. Our foci, negative 4, 1 plus or minus root 29. Root 29 is between 5 and 6, so we can just say 5.5. 1 plus 5.5 would be right about there. 1 minus 5.5 would be right around there. And then the covertices, we're going to move 2 left and right from the center there. So when we draw our box, and our lines through the box, and remember, all those things need to be dashed because they're not part of the actual graph. Okay, and then last thing we're going to do is draw the graphs, following the asymptotes, hitting the vertices, a vertical hyperbola. When ready, I would like you to pause this video and try the third problem on your own. When you finish, unpause the video and come back and check your answer. Okay, here's what you should have got for the third problem. You can pause this video as long as you need to check this out. Otherwise, we are going to move on to problem number 4, which is our last one of these notes. So first of all, it's not in standard form. How do we get it to be in standard form? Well, we got to get this to be 1. So we're going to divide everything by 225 and reduce the lowest terms. All right, so let's go down here. So 1 equals 25 over 225 would be 1/9, so it's y squared over 9. And then 9 over 225. Let's see if we can reduce that to lowest terms. I believe 225 divided by 9 is a whole number. It's 25. So this is going to be our standard form here. Let's put that up there in standard form. Our orientation then would be horizontal. The center of 0, 0. The vertices will move 5 right and 5 left. The co-vertices will be 3 up and down. We'll get there in a second. C squared equals 25 plus 9, which is root 34. So our foci are going to be plus or minus root 34, comma 0, which is almost 6. Almost 6. Okay, so let's plot everything we know. Center at 0, 0. Vertices at plus or minus 5, 0. Co-vertices at plus or minus 3, so 0 plus or minus 3. And if we want to do that right now, we can draw our box right now. Stylus isn't working too great. All right, there we go. And draw in your asymptotes. Okay, and make sure that the asymptotes and the box are all dashed. Of course, they're not part of the graph, right? And then don't forget to plot the foci. So it's just a little bit smaller than 6. So close to 6, close to -6. And then we're just going to follow our asymptotes to infinity. And that's it for our graphing hyperbolas lesson. Thanks as always for tuning in my video. We'll see you again next time.